This video continues in our series of getting started with DesignStart Cortex-M for Xilinx FPGA. In this video we're going to see how to edit the Cortex-M hardware design in Vivado, and in our example we're going to change the UART speed in the design. Although it's unlikely that you'll want to change the UART speed in your own projects, it's this process of making changes to the hardware design, generating a new bitstream image, and uploading it to the board that you need to follow when you make your own hardware changes. So with the Cortex-M processor already in the board's flash memory, and we're using the default M1 design here, let's connect it to our PC and open a new terminal session. So in our setup the board's on port 11, and by default the Cortex-M1 image is programmed with a UART speed of 115,200. So when we push the prog button to reset the board, here we can see the Cortex-M1 banner message. Now let's go to Vivado, and we're going to open the Cortex-M1 project file that came with our DesignStart download, and then we'll change the UART speed in the hardware design. So click on Open Project and navigate to the root of the DesignStart package, which should be in the root of your map drive, and go to the folder Hardware, and then the folder for the processor and the board. So here we're using M1 for RTA7, and then M1 for RTA7 again, and then select the .xpr Xilinx project file and click OK. In the Sources panel, we need to expand the M1 for RTA7 wrapper and then double-click on the block diagram entry underneath. And in a few moments, the block diagram editor will open. And this is the example project that's running on the board. So let's move over and navigate to the UART block here, and then double-click on it to open the settings. In the IP Configuration tab, we can change the frequency of the UART. So let's change it to say 57,600 and then click on OK. So once we've made our change to the design, and after you make any changes to your designs, you then need to click this tick box to validate the design. Here, Vivado checks the code in the design. We see some warnings, but nothing critical, so that's fine. So we can click OK. Next, we click here to generate a new bitstream image file. Then agree to save the project, click Yes as we haven't yet built this, and click OK to launch the run. The new bitstream takes around 20 minutes to build, and you'll see the progress in the top right up here. So when it's finished building, we want to program or download the new image file to the board. Here we're going to open the Hardware Manager, select Open Target and then Auto Connect. And right-click on the chip here, select Program Device, and we'll select the new bitstream file that we've just created. This is in the directory M1 for RTA7.runs, and then in this folder IMPL_1, and here we select our new bit file and then click OK. Then click Program. So now we've got the new image on the board. Let's restart our terminal with the same settings as before. And because we haven't updated the UART speed in our terminal program, we can see that the banner message is warped. So then if we reconfigure our terminal with the UART speed set to 57,600, which is what the board has now been programmed to use, and if we push the top right hand button on the board to perform a soft reset of the processor, we can now see the message clearly. So just to recap what we've done here, first we made some changes to the physical design in the Vivado project block design editor, then we validated the code, generated a new bitstream image file, and then we uploaded this to the board and checked the result. And now that you've done this, you can follow these steps every time you want to make changes to the hardware design and want to verify them on the board.